question one, core one, frequency trees. Get a piece of paper. Let's write down this question, parts A and B on this frequency tree. That sets you up for tree diagrams on probability later on. And fill in the blanks, and let's see how good you are on this. And press play when you're ready. So this question is getting you ready for probability tree diagrams as we discussed. So let's have a quick look and see what this is about. So 150 students enrolled for sixth form. 82 are male. Let's just highlight the key numbers over here. 35 of the 52 Maths A-level students are male. Use this information to complete the frequency tree. So first of all, we're saying that 150 students are here all together. Okay, that's the main crux of it. Now, how many are male? It'll be 82 because simply it says 82 in the question over here. So 82 are male. How do we get to female? Obviously 150 take away 82, 68. Now in this question it says 35 of the 52 Maths A-level students, okay, are male. So where does that leave us? So basically, of the male ones, 35 are over here because they're the ones who do Maths A-level, okay? And the rest of them must be doing, obviously, or the females rather, must be doing the ones over here, which is going to be 35 plus something is 52, is 17, okay? So 35 plus 17 is 52. That's the total number of A-level students. So once we have that, we can simply fill in the rest of these over here. Both add up to, obviously, 35 plus something gives you 82. That's 47. This is non-calculated, by the way. And 17 plus something gives you 68. It's 51. So very simple. You kind of like just eliminating different numbers. Look at the numbers carefully. It's not difficult. It's just filling in the blanks over here. So let's go into part B now. So we have a probability question based on this frequency tree diagram. So one of the 150 people are chosen at random. Write down the probability that this is a female who does not study A-level maths. So let's just find this female who doesn't study A-level maths over here. 68 females and 51 of those don't study A-level maths. So obviously it's 51 out of the total number in sixth form, i.e. 150. So 51 over 150 is the answer. Very, very simple question based on this frequency tree diagram. And let's just highlight that over there. Question 2, core 2. Press pause, write parts A and B down, and press play when you have finished. So Amy's travel commute cost her £1,200 in 2020, and the following year, in 2021, her commute cost her £1,260. What was the percentage increase in her travel cost from 2020 to 21? So this is basically to do with a percentage change, okay? And normally it would say the words percentage increase or percentage decrease, like over here, within the question, okay? And you always deal with two whole numbers as well. So in this case, our two whole numbers are simply going to be this one, 1200 and 1260 as well, okay? So two whole numbers. Now you need to memorize this formula over here. The formula is for percentage change, difference over initial value. So we'll write this over here. Percentage change equals difference all over initial value and times by 100 as well. Okay, and this is a non-calculated paper as well. So let's put this all in a context in a nice box. Let's start with this. So what is the difference, first of all, between this? The difference between 1260 and 1200 is simply 60. Okay, so 60 is the difference. If we look at this over here, difference. Difference over initial value. What do we start with? We started with, in 2020, £1,200. So we have this over this, okay, and we can times that by 100 as well, but don't worry too much about the 100. That will come to us at the end. So first of all, let's cancel a few things out over here. Let's cancel the 0 and the 0 over here. We can divide it by 10 on both sides. So this leaves us with 6 over 120, okay? So again, don't worry about the 100. 6 over 120. Can we break that down? So let's go even further. Let's divide each by the highest factor. That would be 6 in this case. So again, we'll do divided by 6 as well over here. So 6 and 6. So final answer would be 1 over how many 6s are in 120, 20. Okay, now times that 1 and 100. This will give you a 5%. That's something you should know. 1/20th is 5%. So that's how much her commute went up that year. Okay, so look back at that formula. 5%. Right, part B. Sean bought a car for £12,500. The following year, it had decreased to £10,000. So what was the percentage decrease in the value of the car over the year? That's what you want to find out. So let's still apply our context over here. In this case, we're going down, okay? The value has gone down. It shouldn't make a difference whatsoever. So this formula, let's apply over here. So we've got a difference. The difference is £2,500. And that's all over the initial value. We started with, in this case, 12,500. Okay? And that will be times 100 as well. So we're just looking at two whole numbers that give us this idea of using this again, this formula. We're saying 12,500 and 10,000. And this word as well, percentage decrease opposed to increase. But again, that's what these are the buzzwords. Right, so let's have a look and see how we can do this non-calculator. So let's divide each by 100. We're going to divide this by 100 to cancel the zeros. So we get rid of the zeros over here. Those two go and those two go. So we end up with 25 over 125. Okay, so we have 25 over 125. Let's go even further and break it down. Let's divide each one by the highest factor again, which is 25 and 25 over here. 25, 25. So how many 25s are in 25? That will give us just simply a 1. And how many 25s are in 125? That will give us 5. We times that by 100, and 1/5 you should know 20%. So the car has gone down in value by 20%. That's called depreciation, by the way. It's quite a steep figure. Never buy a first-hand car. Okay, so yeah, that's what you should do over here. Look through those two examples of percentage increase and decrease using your percentage change formula, and know what to look out for when you see this question, i.e. two whole numbers. And it's quite straightforward if you understand this formula over here. Question 1, call 1 on basic formulae. Press pause, write parts A and B down, try to make these the subject, and press play when you have finished. So let's make F the subject in this case over here of this formula. So this is our variable, and the others are basically not variables. So, or non-variables should we say. Let's put boxes over here. So 4F is a letter or variable, and all the other ones we're going to put over here like this. Okay, -2 and D over here. Now something over here, we're going to call this a flipper. Now when you want to rearrange to make X a subject, whatever variable you want to make the subject, always try to get that variable on the left hand side. We're going to do a very simple trick over here, and it's flipping them over. Okay, so no sign changes. Literally, whatever we see on the right hand side, we're flipping to the left, and whatever we see on the left, flip to the right. Okay, so look at this flipper. 4F -2 equals D. The same concept. Okay, now we're going to get obviously the same concept as before. All the F's on the left and numbers on the right. So really quickly, let's make these distinct as well. We've got 4F over here. That's our variable. We want to keep on the left, and everything else that's not a variable, we shift to the right hand side. So we've got -2 and D on that category over here. So let's do this and see what we get. We have now 4F equals D plus 2. All the reds go on the right hand side, all the greens on the left. And F simply equals D plus 2 over 4. So that's how you do that. That's a good thing to write down on your toolkit. We'll get to that in a second. But for now, understand part A, the flipper, is very, very important in this case. Part B. So part B, we have 5 minus 3R equals H. So let's make R the subject over here. We're going to make this R the subject. So let's look at -3R. We want to get that at the end, basically. Okay. So let's write this down. So 5 minus 3R equals H. We don't need to do the flipper here because the R is already on the left hand side, and that's the one we really want to make the subject. So if you really want to see this, this is the variable over here. Okay, -3R, and the red boxes we want to shift to the right hand side over here because they're not variables or not letters. So here we go. So we have 3 minus 3R equals H minus 5. Okay, this plus 5, imaginary plus, became minus 5 over here. Now the minus 3 is annoying us over here, the minus 3, so r equals simply h minus 5 all over minus 3. So that is your answer for part B. It's how you make r the subject. So again, make sure you understand both parts A and B to get the full value of this first question over here. Column vectors. Press pause, write parts A and B down on a piece of paper, and let's try to do these questions. Press play when you're ready. And let's attempt the first question, part A. Work out 3a plus b as a column vector. These questions aren't too difficult, so let's look and see what they mean by this. A is our column vector over here. This 3 simply means something called the scalar or the magnitude, okay, which is multiplying this column vector over here, or your direction. So if we look at this, it's the same thing as saying this 3, 4, 1, plus. There's one lot of that. You can put 1 there if you want to, an imaginary 1. You don't have to, if it helps you. Get the same like for like context. Minus 2 and 3. Alright, so this is our scalar in front. This is your direction in the brackets. If we now multiply both the x and the y by the 3, we get this 12. And 3 times 1 is 3. And this simply would be 1 times minus 2, 1 times minus 3 over here. Now let's add like for like. We'll add all the x's together. So let's perhaps call the x's the top number over here in yellow. And let's call all the y's the green ones over here. Very, very simple. So the yellows, let's do this in turn. The yellows would be 12 plus minus 2, which is simply going to be 12 minus 2, which is 10. And 3 plus minus 3, or 3 minus 3 would give you 0. So 10, 0 is basically the answer or the result of this, let's say 3a plus b as a column vector. So let's look now at part B. Part B is the same sort of thing, slightly more difficult, but really the same kind of method 100%. So let's go through this and see what we mean. So A this time is 3 minus 2 and B is minus 1, 4. Work out 2a minus 3b as a column vector. So 2 represents our scalar or magnitude, and 3 over here is, again, the scalar or magnitude on this column vector B. Let's write it out like we did before. 2, which is the 2 over here, by the way. 3 minus 2 minus 3 and minus 1, 4. Okay, so our scalars, again, will be represented by these numbers over here. The 2 and the minus 3, let's say over here, would be these bits over there. Okay, those are our magnitudes. So let's multiply them all in the brackets. We're going to get this. We're going to get 2 times 3, which is 6. 2 times minus 2, which is minus 4. Minus 3, include the minus, by the way. Minus 3 times minus 1. This would give us 3. So we're going to write over here plus 3. And minus 3 times 4 is minus 12 over here. Let's just simply add these together. Same thing. So like for like, we're going to call the yellow ones the x's and the greens the y's. So 6 plus 3. That will give us an answer of 9. And then the y's, respectively, minus 4 plus minus 12, which would give us an answer of minus 16. So we write this down over here. This would give us 9, and this would give us minus 16 over here. That's the result for this. Again, look through these answers. It's not that difficult, but to master this, they're quite nice, easy, non-calculator, grade 5 marks. Press pause, write this question down on Sungjae, how he drives from town A to town B to town C. A typical question on using our speed formula. Press play when you have finished. So let's read this question carefully. Sungjae drives 30 kilometers, that's a distance, from town A to town B. Okay, he then drove 75 kilometers from town B to town C. Okay, Sungjae's average time from town A to town B was 45 minutes, and his average speed from town B to town C was 30 kilometers per hour. Work out the total time for his total drive from town A to C, which is the total amount. So let's split this up first of all into two different, let's say, sections. Okay, so A, B, and C. So this would be from maybe A to B, and maybe a bit longer over here, just approximately B to C. You don't have to do it this way. We're doing a visual way so you can understand this. A, B, and C. So Sungjae, what does he do? So first of all, what do we have? What do we know, first of all, from A to B? Now we know that this is the distance over here. We're going to write D in a circle and 30k. The more variables we know, i.e., speed and time and whatnot, the better it'll be for each section. We have two sections, by the way. This is AB, and this is BC. All right, so he drove 75 kilometers from B to C. So again, this is another distance over here, 75 kilometers. It's always worth writing this down, by the way. Don't look at what the question's asking. Write down what you know from the initial question, the wording, and then the question will be quite easy to figure out, okay, from that. But it's very good to understand what the question is actually saying up front. Sungjae's average time from town A to town B. So time we have over here from A to B again. This is 45 minutes, okay? 45 minutes. Remember, we can convert that as well to a decimal if you wanted to. You don't have to here. Sungjae's average speed from B to C was 30 kilometers per hour. So speed is 30 kilometers per hour. Work at the total time it took. So we want the time variable from A to C. Hence, all we're missing is this time over here. If you find this time variable here from B to C, we can do the question. Okay, so let's think about this over here. We just need this time variable over here. We have the time over here. We need to add it to that bit over here. So time, how do you find out time? It's quite simple. We use our, again, our triangle over here. So if we have a triangle, we have our three variables. We're not given, we should know this: speed, distance, time. Now, to find out t, we cover this up with a finger. It's d over s, okay? Because we're looking at to find out this variable t over here, okay? We'll call it green. So d divided by s, if you do d divided by s, non-calculated by the way, it's going to be 75 divided by 30. 75 divided by 30, that will give you 2.5, 2.5, or 2 hours 30 minutes, okay, because basically 0.5 is 30 minutes. Yeah, you can do this if you wanted to 0.5 times 60, okay, that will give you 30 minutes, if that makes sense. Okay, so 2 hours 30 minutes. So the question is, let's add the total time. So 45 minutes plus 2 hours 30 minutes is simply going to give us 3 hours and 15 minutes. So we'll write this over here. The answer, well, that's 2 hours 30. The answer is going to be this: 3 hours and 15 minutes. That's what he drives from town A to town C. Let's just highlight that. Assuming that he goes at the same, well, he has the same car and same conditions from A to C. Go on, Sungjae. Simultaneous equations, graphical. Press pause. Let's write the values of x and y in this question and press play when you're done. Now, this is a very, very simple question, actually. It looks complex, and what we're doing here is solving simultaneous equations, okay, a pair of them via a graphical style. So it says solve the simultaneous equations. It gives 2x plus 3y equals 12. That's number one, let's say. And number two, y equals x minus 1. Now, all we do is this. We don't look at this algebraically. We look at it graphically. These two lines are already plotted over here. This one, this linear form, this is in the form of this line here. Okay, and the other one is such that we'll put this green color code. This again is a linear in terms of an explicit form, y equals mx plus c. All we do is this keyword intersection. That's what it comes down to. Where do these two lines cross? They cross over here. It doesn't take anyone to really realize that, okay, and the easy marks for this. So this is going to be obviously 3 across over here and 2 up. So 3 across, okay, and 2 up would be 3, 2. X would be 3 and y would be 2. Simple as that. So the keyword is intersection, okay, and that's one of the stepping stones on your maths memory cards. applied algebra. So let's get down to this question, a very typical question on the ages of 3 different students, let's say, and let's try to find out the age of Amy, Ben, and Carl respectively. So write this down, try to find the ages, use a bit of algebra if you can, and press play when you're ready for the answers. Now Ben is 5 years younger than Amy. Okay, Carl is double Ben's age. Okay, so the sum of the ages is 33 years old. So first of all, let's try to identify this question. Okay, step one is always try to identify the problem. Okay, let's identify, we could say, the context. So this is definitely to do with ages of 3 different pupils. Now, it's always good to represent a pupil with the, let's say, letter X, okay, because X is your base, and that's the kind of scenario you want to think of when you see a question like this, especially with 3 pupils. They always have 3 pupils involving ages, okay? So let's take each one of these in turn. Now, Ben is 5 years younger than Amy. We can't do Ben because that's relative to Amy. Carl is double Ben's age, so we can't do Carl because that's relative to Ben. You know, we didn't know Ben before. So Amy must be your base. So Amy has to be X. Let's do Ben. Now Ben is 5 years younger than Amy, so obviously he would be X minus 5. See how we're creating expressions, individual expressions for each of these pupils respectively. And Carl is double Ben's age. Now Ben is X minus 5. What we'll do, we'll put a bracket there because we have 2 of these, remember. We have 2 and X and a number. Put a bracket. He is 2x minus 5. A bit tricky, but that's the first thing. Identify context and represent them each in terms of individual expressions. Step 2, let's create an expression from this, okay? So create an expression. Now these 3 steps don't always hold for this topic, applied algebra, but it's worthwhile going through these now. There may be bits and elements of this in the question. So create an expression, literally it's very simple. It's A plus B plus C, okay? So it's X plus X minus 5 plus 2x minus 10. Look how we expanded this out over here. And each one of these represent the 3 different pupils respectively. So we can put little boxes here, x minus 5, and 2x minus 10. This is Amy, A, B for Ben, and C for Carl. Okay, now the third step is to create an equation. Equation simply is an expression with an equal sign after that. So step 3, let's create an equation. Equation is very, very simple. So let's go one step further, in fact, and let's simplify this. We forgot to do that, okay? How many x's do we have? We have 1x plus 1x plus 2x. So the final answer for this would actually be, if you look at this, 4x, and how many, what are the numbers? Minus 5 minus 10 is minus 15. So that's your expression, 4x minus 15. So an equation would say that 4x minus 15, that's the sum of their ages, has to equal this number over here. They both equal each other. So that's your equation, and obviously common sense says to find x now. 4x equals 33 plus 15, because that minus 15 becomes a plus 15, and therefore 4x equals 48, and x would simply be 48 divided by 4, which would be 12. So x would be 12. Once you have that, we can work out the respective ages. Now x was obviously, was x is 12, Amy is 12 years old. Ben would be x minus 5, so hence he would be 7. And Carl would be double Ben's age, 14. How do you check it? All 3 should add up to 33. Let's double check it. 12 plus 7 is 19. 19 plus 14 is 33. It's a winner. Okay, so you can always check it like that. It is not required, but all of these should add up to the original number in the question. Okay, that's a check. We like it. So that's how you do this question over here. It's quite simple in terms of the base, but the base is the key thing to understand in this and to find out what the value of x is, like we have.